Solving systems of equations graphically. Lesson 9 notes. Example number 3. Just like examples 1 and 2, we're going to graph these equations to determine our type of solution. The best part about example A, or equation A, I should say, is it's already in slope-intercept form. In other words, it's already solved for y. So that means my slope is this number in front of x, and the y-intercept is the number behind x. So my slope is negative 2/3, and my y-intercept is positive 1. Because the slope is negative, it's going to go down and to the right. So I'm going to go ahead and graph that. I start at positive 1. I go down 2, to the right 3. Down 2, to the right 3. Now I go the opposite direction. Instead of going down, I will go up 2, and then I'll go to the left 3. Up 2, to the left 3. Up 2, to the left 3. Extend your line past the grid lines. Put your arrows on the end. Label that example 3A. Okay, let's go to line B. Unfortunately, x and y are on the same side, and y has a coefficient, so that means it's going to take 2 steps to isolate the y. First, I'm going to box that, knowing that that's my last step. So I need to take the 2x to the other side of the equation. It's positive 2x, so I will subtract 2x from both sides. They cancel. Bring down the 3y equals negative 2x plus 3. Now I divide everything by the coefficient of y, which is 3. They would cancel. Negative 2 over 3 does not reduce, so it will stay negative 2/3 x. And 3 divided by 3 is 1. So if we take a moment and let's look at this equation up there and this equation here. Y equals negative 2/3 x plus 1. Y equals negative 2/3 x plus 1. So they're the same line. The slope for this line is negative 2/3. The y-intercept is positive 1. They are the same thing. So that means my slope of line A equals the slope of line B. Y-intercept of line A equals the y-intercept of line B. If they are equal to one another, both the slope and the y-intercept, they are called coincident lines. We can just abbreviate that. But these will be coincident lines, which means one lies on top of the other. So, you don't need to do this. Because it's the same line, all you need to do is put 3A and 3B. But I am going to show you what it looks like overlapping one another. I'm going to use a dotted line to do it. Okay. So if I blow it up a little bit, you could see the solid green line was 3A, the dotted purple line is 3B, but they are the same line. So how many points do these two lines share? That would be the number of solutions they share. Well, how many points are on the line? An infinite amount. Therefore, my answer to this problem is infinitely many solutions. There are infinitely many solutions that would satisfy both equations. Pause your video, make sure you have all of that written down. All right, I want to show you what it looks like in the graphing calculator. Because this is coincident lines, I want to show you in not split screen because it's a little bit easier to see. So I'm going to pull up the graphing calculator here. All right, let me delete. All right. Oops. If I go up here. Sorry, we'll just go back to. There we go. Clear all. I'm going to get rid of the, I like just the major grid lines. So go to input. Let's start with the equation A. So it is y equals negative 2/3, so negative 2 divided by 3. Hit the over arrow, put the x, and then it is plus 1. So negative 2/3 plus 1. Now I'm going to graph the next one, which is 2x plus 3y equals 3. Hit enter. All right. Okay, now watch when I tap. So that's the purple line. Watch when I tap the top equation again. And see how it puts like that glow behind it? So there's the one line, there's the other line. So I don't know if you could see that. I don't know if it zoom in. There's one line, the other line. They are the same line. It's kind of hard to tell, but the glow does behind the line changes as I press each equation. Anyway, you can see that the graph gives you the same line. Therefore, they are coincident lines. If you have any questions on example number 3, please do not hesitate to ask.